Hey guys, welcome to lesson 3 of Unit 10. Our topic today is probability addition rule or. So your addition rule has to do with or. We learned about and in lesson 2. Today we are going to be focusing on or. So the do now says in probability an outcome is an event A or B when the outcome is in either or both event A and event B. So what would you describe the sentence above as being a union or an intersection? Explain your reasoning. So let's talk about intersection real quick. Intersection is when the event happens in both. It has to be in A and it has to be in B. It cannot be either or. But union, or for that matter, intersection, we use this symbol. Union, we use this symbol. This is the symbol for union. Union is if it is in either one. So it could be in event A or event B, or it could be in both. So that is what your union is. So or is your union. So let's write that down. Because the outcome is in either A or B or both. Okay, probability rule for or, addition rule. You have to memorize this, guys. You must know this. How do we read this? The P stands for probability, okay? Probability of A or B. So you'll always be asked about two things or two events happening. So what is it? It's probability of event A plus the probability of event B minus the probability of A and B, which has to do with your overlaps. And if I was to use the symbol, it would be probability of A and B. That's how I write it, right? And eventually you will see that, sometimes maybe probability of A or B is given to you. Probability of A is given and B is given, and you have to find this. Or there are 4 unknowns. 3 of them will be given to you and you'll have to find the 4th one. It could be either or, right? For most part today we are going to be focusing on finding probability of A or B. So we will be given enough information to find probability of A, B, and probability of A and B. So let's get started with example 1. A dice is rolled. What is the probability that the number is even or less than 4? Okay, so there are a few things that we need to keep in mind. Probability is always a number between 0 and 1. Okay, if something is never going to happen, the probability is 0, and if it is surely happening, then the probability is 1, or we can say 0 and 100% if you're talking in terms of percent, right? So in this question it's saying a dice is rolled. So how, if you roll a dice, you've all seen a dice. If you die, I would say die because we're talking about 1. If you roll it, how many possible outcomes are there? There are 6 possible outcomes. N is equal to 6. That's your sample space, right? So it's saying your first event is probability of a number is even. So let's call it capital E. So it's either even or has to do with union less than 4. Less than 4. So that would be what? If I look at the rule up here, it's probability of the first one, which is probability of even plus probability of number less than 4 minus the overlap. There is a possibility that you have an even number and a number less than 4. So how do I find this? Okay, we already know our sample space is 6. So let's write out what are the out 1, 2, 3, 4, 5, 6, right? These are the numbers on the die. So how many even numbers do you have? So I have 1, 2, 3. I have 3 out of 6. The probability of even numbers is 3 out of 6. Probability of numbers less than 4. So how many numbers are less than 4? 3 again, because 1, 2, 3. You're not counting 4 because it said strictly less than 4. So 3, again your sample space is out of 6 because we're talking only about 6 numbers. And then lastly, it's talking about how many numbers in this, in these are even and less than 4. They're both. It's just one number that's even, which is 2, right? Less than 4. So there's only one number out of 6. So that's how you come up with these probabilities. So 3 plus 3, your denominators are same, right? Your LCM, you find the common LCM, it's 6. And your numerators, you're just going to add them. 3 plus 3 is 6, minus 1 is 5. So it's 5, 6, or you can divide it. 5 divided by 6 is 0.83. That is also an acceptable answer. I said probability is between 0 and 1, right? 0.83 is between 0 and 1. Or if you want to write it as percent, it is 83%, okay? The next one, a standard deck of cards is shuffled and one card is drawn. Find the probability that the card is queen or an ace. Okay, let's talk about the cards first. A standard deck of cards usually has 52 cards. Your n is equal to 52. There are 52 cards in a standard deck and they are in two colors, dividing them equally. So you have 26 red and 26 black cards, right? And then there are 4 suits. If I was to talk about suits, I'm just going to quickly do. There's diamonds. Then you have, oh wow, that's a nice one. Then you have spades. Spades, I can't really draw it. I'll try. It looks something like this. That's what your spades looks like. Clubs is like a clover. That's what your club looks like. And then you have a heart. Okay, so these are 4 suits and each 4 suits contains 13 cards, right? So from ace till king. Ace is usually considered 1 and jack is your, or jail is your 11, queen is your 12 and k is your 13. You don't have to know all this in details, but yes, it's good to know at least that there are 52 cards, 26 red, 26 black, and there are 4 suits, right? So each suit has 13 cards, right? 13 times 4 is 52. So that kind of makes sense. So now let's go here. It's saying find the probability. So I want to find the probability of a queen, which would be Q. I'm going to use Q for queen, and an ace. Or an ace, not and. Or, be very careful. Or means union ace, which would be A. So what's the probability of queens? How many queens are there? There are 4 queens, right, in a deck of how many cards? 52. How many? Let me first write down the rule. That way it'll make it sense. So we'll write down the rule for each one. So it'll be probability of Q plus probability of A minus probability of Q and A intersection, right? So what's the probability of Q? There are 4 queens out of 52. There are how many aces? Again, there are 4 aces out of 52. And are there any cards that are queens and aces? No, there are none. So it's 0 out of 52 actually, or you can just say 0. So denominators are same, add the numerator. So it's 8 out of 52, which is same thing as 4 over 13, right? Which is same thing as 30.7, or I can say 31%, 0.31 or 31%. Okay, so now let's talk about a complement of an event or not. Okay, I will give you an example before I even get into it. If I said it's a 40% chance of raining today, what's the chance it won't rain? You'll say 60%, right? So what's that? Not raining is the complement of raining. Okay, so complement is if a event within the sample space S is of an activity or experiment, we have seen that the complement of A, which may be written as A complement, we also write it as this, consists of all the outcomes in S that are not in A. Okay, so the complement of A is everything else in the problem that's not in A. So raining, not raining. The probability of the complement of an event is probability of A complement. That's how you read it, is 1 minus the probability of A. And I can say the same thing. A probability of A is 1 minus the probability of A complement, right? So let's do this question. A gumball machine contains gumballs of different colors. I don't think so. This give was to be there. 36 red, 44 white, 15 blue, 20 green, and 5 orange. The machine dispenser randomly selected one gumball. What is the probability that the gumball selected is? And we have to answer those questions. Again, we need to know our sample space, right? How many total gumballs are there? So 36 plus 44 plus 15 plus 20 plus 5 is 120. That's how I got my sample space, right? So now it's like you have them in the gumball machine, and if you turn it, which one will come up? What is the probability that I'll get green, right? We all have our favorite colors. So probability of green, just green. How many green are there? There are 20 green out of the total sample space, which is 120. So 20 divided by, you can simplify this, or you can even write it as a fraction. So 20 divided by, this is actually 1/6, or I can say 0.17 or 17%. It's 1.666. So either or, right? I'm not going to keep doing percents, but I just want you to make that connection, that you know what, it is a percent. That whenever we talk about probability, it's talking about what percentage are we saying that this event is likely to happen, because it's a probability, right? So if it's surely going to happen, then the probability is 1 or 100%. If it's surely not going to happen, then it is 0% or 0. Okay, so not green. Whenever we see the not thing, either I can add everything else besides green and then write it out of 120, or I can do it better. I already know the probability of green is 1/6. So going about my complement, probability of green complement will be 1 minus probability of green, right, which is 1 minus 1/6. So I can rewrite this 1 as, can I not rewrite it as 6/6? Right, 6/6 is just 1. So 6 minus 1 is 5/6. Or you could have done the butterfly method. Some people like to choose it. So anyways, 5/6 is, we already saw that in the last page, 0.83 or 83%. Now not orange. Again, find the probability of orange. What's the probability of orange? Probability of orange is 5 out of, let's write this down. Probability of orange is 5 out of 120. So probability of not orange will be orange complement, which is 1 minus probability of orange. So 1 minus probability of orange is 5 out of 120. Can I rewrite 1 as 120 over 120? 120 minus 5 is 115 over 120. So 115 divided by 120 is 95.8%. So I can either write it as 0.96 or 96%. Okay, not red, white. Part D. It says the probability of not red. So let's write it down. Not red. So red complement, neither white, white complement. So union, not comma, I'm sorry. And not blue, so blue complement. So what's the probability of red complement? The probability of, if it's neither red nor white nor blue, how many am I left? So I don't want to count red, I don't want to count white nor blue. I'm left with what? Just green and orange. So it is what? 25 over 120, or I can even say this is what? 5 over 24, which is same thing as 20.8%. 20.8%, which is basically 21%. Or I can say 0.21, right? Okay, I'm going to do one last one, and then you can finish the remaining for homework. In a hospital unit, there are 8 nurses and 5 physicians. So how many total are there? 8 plus 5 is 13. So your sample space, or your n, is 13. We use lowercase n. 7 nurses and 3 physicians are female. So think about it. If 7 nurses are females, then how many nurses are males? 1 male. I've not even read the question, but as I'm going, I'm trying to analyze what other things it means, right? So because eventually, not always will it give you all the information. You have to deduce the information from what is given to you. 3 physicians are females. If 3 physicians are females, then 2 physicians are what? Males. Right, so 1 nurse is male, 1 nurse male. Oh, I can't spell. Nurse male, and 2 physicians are males. If a staff person is selected at random, find the probability that the subject is a nurse or a male. So these are your 2 events. So probability of nurse or will be union male, which would be probability of nurse plus probability of male, minus probability of nurse and male. So what's the probability of nurse? How many nurses are there? 8 out of how many total physicians out of the sample space? 8 out of 13. How many males are there working all together? We have 1 nurse male and 2 physician males, so 3 out of 13. And how many are nurses and males? There is only 1 who's a nurse and male, so 1 out of 13. So add these up. Your denominators are same. Add the numerators. 8 plus 3 is 11 minus 1 is 10 out of 13, right? So that's basically it. You can, if you want to write it as a decimal, you can, again, it is approximately 77.77 or 77%. Okay, so for your homework, please finish the remaining remaining questions. And if you have any questions, please reach out to your teachers.